So, can you see the screen now?
Yes.
Okay, so we are going to start this, then later we move to 1220 and try to see how we can go about problems. So we are going to solve all the exercises under force, impulse and momentum, work, energy and power. So we have about 10 examples which we are going to see, or exercises which we are going to see. There are about 10 questions under these exercises, so we are going to see them. The first one we know is this. So I hope you can see the screen. I hope you can see the screen. Okay, so now let's start. We have a solution here to solve. A hammer is moving horizontally at this when it strikes a nail and comes to rest after driving this into the board. Assuming constant acceleration of the hammer's tail pair, calculate the duration of the impact. So here what we want to find. So what we want to find here, we want to find the time, and else we want to find the force. So from the data given, we are given the mass to be 0.450 kg and the horizontal velocity, which is the initial velocity, which is 7 meters per second. When it strikes a nail and comes to rest, so when it comes to rest, the final velocity will be 0. After driving a distance, the distance here is 1 centimeter. Because it comes to rest, that's why the final velocity is 0. 1 centimeter, when you convert it to meter by dividing by 100, you have 0.01 meter. So now we need to calculate time and force. For us to do that, we have to apply the kinematics equation of final velocity is u square plus 2as. But remember, v is 0, so we have 0 is equals to u square plus 2ax. So from there we can get our acceleration. If we make it the subset of the formula, we're going to have minus u square over 2x minus, and our velocity is 7 square. That is u square times 2, and our x is that of 0.01. So when you do the division, you are going to have minus 2450 meter per second square. The minus is because the body is slowing down. That's why it comes to rest. Then now let's now try to find the time. Also applying the equation of motion, v equals to u plus at. And already we know that v is 0. Our initial velocity is 7. Then acceleration is minus 2450. Then we are looking for time. If we make t the subset of the formula, we can see that time is going to be I'm coming, let me see, of course this is plus VAT. Then make t subset of the formula, we are going to get then 7 divided by 2450, and that will give us 2.9 times 10 to the power of minus 3 seconds. Then finally the average force is going to be mass times the acceleration. The mass is 0.450 and acceleration we have calculated is minus 2450. Then our answer is we are going to end up having 11002.5 Newton. The minus because the acceleration is negative, and also the force will be negative because they are in the same direction. So this is the time for which the collision lasts, and this is the average force exerted. We apply the equations of motion, this and the other ones. We have this. So that is how to solve this example 1. But to find time and that of force. and we use this equation when anybody come to rest v is 0. So that's how we solve this example. So I hope it's clear. Okay, so now let's move to the next one. The next example is this. So the next example, we're going to say that a particle of mass. So right from there, we just look at the mass. The mass is just 5 kg. Then moving with a velocity. The question says, the first one says, what is the momentum of the particle as a function of time? So we know momentum, P, is mass times what? Velocity, right? So mass times velocity, that is momentum. Then again, but velocity is the change of distance over what? Time, which we defined previously, that velocity is change of displacement over time, and displacement is a function of time. So put the value of m, we're going to have 5 derivative of x of t with respect to time. So that is the answer. So we don't know our displacement, so there is no way we can get the final. So that's why they say you put them in the time, in terms of what? Time. That is a function of time. Velocity is displacement over time. That's how we write it in differentiation. The rate of change of distance with what? Rate of change of displacement with time. That is velocity. Then the B part, we have to find what? What is the net force acting on the particle? The force, also, we know force is mass times acceleration. Mass. What is acceleration? D, that is the rate of change of velocity. That is the rate of change of velocity over rate of change of what? Time. So now we put mass. Then what is velocity again? Velocity again is the rate of change of distance over time. So therefore, that's we're going to have d over dt. That is this. Then this v again, that is that d of xt over that of dt, because this v is this velocity and this d over dt is here. So dd, we're going to have md square, then of displacement over what? d that we have dt square. Then put the value of m, we're going to have 5 d2 x of t over dt square. So that is how we do it. It's just a simple thing. We know velocity is distance over time, and acceleration is rate of change of velocity with time, which is the second derivative of displacement with time. That is acceleration. Substitute the values. That's how we obtain these values. So the next one, so there's somebody have to have a question. Do you have a question? Who have a question? Yes, who have a question to ask? I think that is a form. So this is velocity, this is acceleration. You just copy and paste. That's all. Momentum is mass velocity. This is how velocity is. Displacement over time. Acceleration is this. That's all. This is force, ma, and this. You just replace the value. So, and that is how we do it. And number 3. So we have number 3. Number 3, we have calculate the final speed of a 110 rugby player who is initially running at this, but collides head-on with a packed goalpost and experience a backward force of this for these seconds. Calculate the final speed. Remember, we are going to find the final speed. That is Vf. We are given the initial speed Vi is what? Is 8 meters per second. The mass of the rugby player is 110 kg. And the force F, because it's a backward force, so it's going to be minus. So I'm going to have minus because it's a backward force, 1.76 times 10 to the power of 4 Newton. That is a backward because it's minus. Then the time for which this collision lasted is 5.5 times 10 to the power of minus 2 seconds. Now we want to find the final speed. So this one is the issue of momentum and impulse. So we have the formula that is force times time is going to be the mass, the final velocity, minus the initial velocity. So this is what we have. Now what we want to make the final velocity the subject of the formula. Divide both sides by m. We have Ft over m is equals to v final minus v initial. So therefore the final velocity, if you move this one to the left, it becomes plus. So it's going to be initial velocity plus force times time over the mass. All you need to do is to substitute the value of the final initial velocity is 8. The force, remember, is minus 1.76 times 10 to the power of 4. The time is 5.5 times 10 to the power of minus 2. All divided by the mass. The mass of the rugby player is 110. Here you are going to have 8 plus minus is minus. When you divide all of this, you are going to get 8.8. When you subtract, you are going to get minus 0.8 meter per second. So you see the issue is minus. That's why if you hit the head on the wall, your head bounce back. And that's why you have the minus, because it's going to come back. The minus because it's head on the goalpost. So that's why the head will come back. So the head cannot pass through the goalpost. So it has to come back. It has to bounce back. That's why we have the minus. So the final velocity will be the minus. And the body is going to slow down because of the impact that this force acted. That's why you see the initial was plus 8. Then after which the velocity reduced down to 0.8, but in the opposite direction. That is going to come back a little bit. So, and that is what we have. So this is the formula we use to solve this kind of problem. Impulse, force, time is equal to a change of what? Momentum. That is how we solve example 3. It's a very straightforward question. So it's a very straightforward question. So that is for example 3. Now let's move to example 4. So example 4, a gun fires 8 bullets per second. A gun fires 8 bullets per second into a target if the mass of each bullet is this and the speed is this. Then calculate the power. So what we want to find the power. Power is question mark. But here the time when the gun is shot is 1 second. That is per second. That is 1 second. Then the mass of the bullets. There are 8 bullets and each bullet is 3 grams. So we're going to multiply 8, the number of the bullet, by each, which is 3 grams. This gives us 24 grams. Then you convert this one to kilogram. You divide by 1,000. When you divide by 1,000, you are going to get 0.024 kg, because that is total mass of the what? Of the bullets coming after 1 second. Then they will hit a target at this speed. Each of them speed. So the average speed is the same. The velocity with which they will strike is going to be also 600 meter per second, because they are the same. Even if you are going to add all the velocity, you divide by 8, you are still going to get 600, because it's the same thing. The velocity of each bullet is the same. So if you add them, divide by the number 8, is still going to give you 600. Now we want to find power. So therefore, power is energy over time. And now which energy the bullet possess? It possesses kinetic energy, which is half mv square. Because the bullet is moving, so it possesses potential and kinetic energy over the time. Then the half 0.5, the mass is 0.024, and the velocity is 600 to the power of 2. The time is just for 1 second. Whatever you do, at the end you are going to have 4,000 4,320 watts. So this is the power. The power delivered by the bullet. So the power is 2I is 43,200. So if it's just one bullet, the power should have been very high. That's why you see it's not easy to operate this kind of gun that sprays 8 bullets per second, because you need enough power, because the power is coming. If it's just one bullet, it will divide by 8. That value will be smaller. So to operate a gun with just 1 bullet per second is easier than to operate a gun with 8 bullets per second. That's how the power comes in, because the power will be too much to operate. That's how we do. Yes. What happened?
I have a question, sir.
What's the question? You have to be fast.
The time we are actually 8 seconds since each bullet is taking
What?
1 second.
What you said?
The time, sir.
The time is 1 second. Is per second.
8 seconds.
No, it's X target, as into a target X. There is a point where the bullet hits. That is a target. This is X into a target X. So you just shoot. We don't know where the target, whether it's a car, whether it's somebody, or whether it's a wall. Just for 1 second. What is the power? If you are going to operate just 1 second, so this is what you are going to do. So if you are going to be operating it for let's say for 1-2 minutes, the power will be too much to operate this gun for those 2 minutes on your hand shooting like this. It's not going to be easy. But for those 1 second, just see the amount of power. If you are going to do it for those 3 or 6 minutes, the power will be too much that will be coming. So that is what you have to take note of. Then the example 5. Example 5, a box is pulled with a force of this to produce a displacement of this. So a force is pushed to a displacement of this, then at an angle of this. So this one is a straightforward question. Force is 25 Newton and the displacement is 15 meters. The angle between the force and displacement is 30. So the work done is going to be force X cos theta, because the force is not in exactly the same direction of displacement, but they make an angle of 30 degrees. So you substitute. That's why we have Fx cos theta. The force is 25, X is 15, cos of 30 degrees. So if you multiply, you are going to get 324.8. This is in Newton, and that way I have meter. Now, Newton meter has a name. That name is also Joule. So Joule is Newton meter, okay? So that is Newton is the name of scientists. Meter is not the name. So Newton meter is same thing as what? Joule. So that's how we solve this type of problem. Very straightforward. Work done is this. Fx cos theta. That's what we have. So we have the next one. So we have the next one. Let's see the next one we want to solve. That is example 6. If an object of mass this is thrown up from the ground and reaches a height of 5 meters and falls back to the earth, that is to the ground back, neglect air resistance. Calculate the work done by gravity. So here the question here, work done by gravity. Work done by gravity when the object comes to the earth. So let's see, let's get the data first. Mass is 2 kilogram. The height is 5 meters. We can take our G to be 10 meters per second square. Calculate the work done by gravity. Okay, so now the work done by gravity, is going to be mgh. That's what we have. The work done by gravity is going to be mgh. The mass is 2. The G is 10 and the H is 5. So when we do that, we are going to have 100 joule. That is to reach height this. To reach this height this, so at that particular height, the work done will be this 100 joule. Then B part, the work done by gravity when the body comes back to the earth. Okay, work done is going to be 0, since displacement is what? 0. The body goes up, it lives on this ground level, that is the x initial, it goes up and falls back on the ground at x final. So you can see, so the displacement here will be what? Will be 0. It comes and goes, so the work done will be 0. So the total work done will actually be 0. Even though the body goes up, that, but the displacement will be 0. So the total work done is 0. Once the body go up and come down, it's going to be 0. So the work done, because of that displacement, is going to be 0. That's why we put 0. So the body comes back to the level. But if the body doesn't come back to a particular level, maybe somewhere here, then there will be a work done. But if it come back to the ground from where it was thrown, then the work done is 0. So that is what is work done is going to be 0. But this one is to the height. When it reaches a height, this is not on the ground. So that's how it apply. So why is it? That's why I said you have to find the height. It's the same question like A. So you do the same thing with A. You do the same thing with A. A is the height. Once you give in the height, you can find that of the energy that's required. It's a function of height. So if it's come on the ground, so that you don't have that one. So now let's see example 7. Example 7, let's see 7. A weightlifter, somebody that can lift a weightlifter lift a mass. The mass is 250 kg with a force. The force is 5,000 Newton to a height. That height is 5 meters. We can take our G to be 10 meters per second square. Now the first question, 2 things are happening. The mass, the load is on the ground. It's on the ground. This person raise up this load to a particular height and leave it there. That height is 5 meters. They leave the load here on top of this height. So this is the weightlifter. I lift the load to the 15 of that 5 meter. What is the work done by the weight? That is by this person that lifted it to this. So the work done is going to be, now it's going to be force times the displacement, which is the H. The force the person uses, and that of the height to which it raises up. And this one, so this is a force done by the weight lifter, not by gravity. So the force is 5,000 and the height is 5. If you multiply the 2, when you multiply the 2, you are going to get 25,000 joule. You see, it is a very huge work has to be done to lift this load to a height, because you are going against gravity. Then B, what is the work done by the gravity? So by gravity, and please, the noise, please. Oh, why are we making the noise? Somebody is making the noise. I don't know where the noise is coming from. So let's see the other one we want to solve. That is, we want to do the work done by what? The now is by gravity. Now, work by gravity. Now the load is already here. Then, if this load is to go down, then we don't need this man again, because gravity will bring it down. That's why the work is now done by gravity. If this object is to release, nothing is needed. The gravity will bring it down. So the work done is going to be mgh. So the g comes from gravity. So they put the mass is 250. The g is 10. And that of the h is 5. If you multiply, then you are going to get 12,500, which is less than that of when it goes. That's what it is. It is not easy to lift an object than to allow it to fall. To fall is easy, but to lift is not easy. That's why you have these two. Work done by gravity is mgh. Work done by any other object is force times that distance. That is it.
So what is work done by gravity is greater than that work done by electric?
I'm not. That should not be a question. It's not that may be possible or maybe not possible. All what we are saying is that once it's by gravity, the mgh. When it's done by another agent, is the force times the distance. Yeah. So that's what we have to take note of. Then the example 8. Example 8. So the who want to talk? Talk. I can hear you. Kautar. You said? C part. C. You see the noise? Somebody is making the noise. Who is making this noise? So let me check and see. You said that is it C part. The noise is too much. So people are making this noise. We have to listen. Let me check. You say question 7. There's a C part. 7 says, what is the net work done on the object? So the net work done, you are going to subtract the 1 you have done to do. Work is done by the gravity with the force of this to the height of this. So the net work done, you are going to subtract them. So for that question 7, the net work done. So then net work done. Because the gravity, it is going to bring it down. So the net work done is going to be that of the two values, that is 25,000 minus what? 1,500. So whatever I have, so that is a way to go about it. Then number 8, let's see number 8. The noise, you can see the noise. You are in the place where the environment is noisy. So you see, in the place where the environment is noisy, that's why it is. You cannot able to actually see what you are doing. Please, I'm saying the other time, you have to mute your this thing. Use a this thing, headset. So use your headset or use your earpiece. You have to use your earpiece if you are doing all these things. You cannot be doing like this, open your phone and be talking direct. So now we have this. Now let's see what we have. We have example 8. Example 8 is this. Calculate the energy consumed in electrical units. And what is electrical unit? Is 1 kilo, that is 1000. W is watt hours, which is normally like the PHN here in Nigeria. When this 75 watt fan is used for 8 hours daily. So it uses for what? 8 hours for every day for 1 month. And that 1 month is 30 days. Now, let's start with our power. Our power is 75 watts. So all we need to do, let's convert this power to kilowatt. That is, we say 75 divided by 1000. So that we put kilowatt instead of just watt. Because kilo is 1000 divided by 1000 is this. So we now convert them. So if we divide by 1000, we have 0.075 kilowatt. We put them in this unit, just by dividing by this, we now have in kilowatt. The same thing, not different much. It's the same thing with that. Now let's get the time. The time, we are going to use it for 1 month. Then after 1 month, you are going to pay the bill, electricity bill. And for each day, you are using it for 8 hours. So 8 times 30 times. That is for 30 days. That is in 30 times. That is 8 hours in 30 times. That is 8 hours daily for 1 month. That's why we have 80. That will give you 8 times 30. If we multiply 8 times 30, we are going to get 240 hours. That is 240 hours. Then now, we now want to find that energy. The energy now is power times time. So this is electrical energy. It's always power times time. Power is now 0.075 in kilowatt. That is in kilowatt times time is 240 H. So now if you multiply them, you are going to have 18 kilowatt hour, which is just 18 electrical units. That is, you are going to be charged for 18 units. So that means you have used 18 units for those using this fan. 8 hours a day. After 1 month, then you are going to pay this charge for 18 units. So this is how we obtain the value. You convert the power to kilowatt by divided by 1000. You convert the time to hours because it's 8 hours in 30 times. That is in 30 days. So we have this hour. We multiply this with this. Then whatever you have, that is the electrical unit. Electrical unit, that is this. 1 kilowatt hour is the electrical unit. So this is how we do question 8. Straightforward. Who want to talk? Yeah. Because see the electrical unit, because of our electrical unit, we wanted our time to be hours. You see, our energy is supposed to be power times time. But now we want our hour to be hour. That's why I say hour. That is the unit they use in electrical this. The time is an hour. That is how they charge. So they're not using second there because second is going to be very, very, make the value so large. So the hour will make the number very small. If you are going to use seconds, this should be like millions. So it looks so large. So they reduce it to hours instead of using seconds. So this is what they normally use there. So that is how it is done over there.
So what if the unit is not indicated in the question? Then we get the
No. You just convert everything to seconds and the power will remain. You just leave the power 75, multiply with time in seconds. And that is how you do it. So,
okay, thank you, sir.
yeah, okay. Okay, who is Gift? I think Gift want to say something.
I just said something. I asked about it.
Okay, no problem. Okay. So, okay, now let's see. Wow. Okay, now let's see example 9. We have example 9. Second to last. Example 9. Say a vehicle of mass this is driven with an acceleration of this along a straight road against an external resistive force of this. calculate the power delivered by the vehicle's engine if the velocity of the vehicle is this. So you see, in this problem, you have a vehicle that is moving forward, then along the road, but it is coming out due to breezes, due to other things like bad roads. If another force is coming somewhere, maybe like the breeze, or is going against something, and that force is 500 Newton. So that force is 500 Newton. So we have this force of 500. So this car need to overcome this in order to move along a straight road, and the acceleration is 0.2 meter per second. The mass is 1250 kg, and the resistive force Fr, force due to resistance, which is opposite the motion, you need to overcome it, and that force is 500 Newton. Then calculate the power. Now let's see the formula for power. Mechanical power is force times velocity. So because that is what we normally have, if you are going to take any of the formula, you see that we end up having force. Because if you take like power, you take this mgh, there you now see, okay, now mg is the force, which is the weight, like a force. Then no, I'm sorry, there we have this power is energy over time. The energy will take the mgh over time. You see, this mg is just like a force. H over t, distance over time, is velocity. That's why we always say the power is force times velocity. So it's another formula for power. Power is force times velocity, or energy over time. But here we have two forces we want to overcome. The first force, so we're going to put a bracket here, multiply with our velocity, which is v. Our velocity here is this. Sorry, we didn't put our velocity. Our velocity v is 30 meters per second. So the first force for the car, because the car is already moving, so the power of the force for that car is going to be mass times acceleration from the car. So this force also need to be what? Added. So in order to able to do something, that's why we put 500 plus 500. We need to add it because it's going the opposite direction. But if the force is going, just like, let's say you are moving the car and there is a breeze somewhere that is pushing it, so there will be less power to do that, because so that will now be difference. So here we need to overcome this one. Velocity, the velocity here is 30. This is the velocity. Then our m is 1250. The acceleration is 0.2 plus the force, which is 500. We need to add it up. Then times v. What is the v? So so I'm sorry, it's minus. So I'm sorry, it's supposed to be minus, not plus place. So it's going to be minus. Then because this is, so it's going to end up slowing the what? The power of the car, because the wind, this opposite will try to slow. So it's going to be minus. I'm sorry, it's when this we're going to have this. Then v is now that of 30. So if we multiply and see, we have 1250 times 0.2 minus that is 1250 times 0.2 minus what? 500. So we are going to have what? So we are going to have minus 250 times 30. Okay, no. We need a plus here, and power cannot be negative. Power cannot be negative, so we need a plus. I'm sorry, we need a plus here in order to overcome it, because the car has to move. So you need more power to go when something is coming against. So the power needs to be high. So we're going to cater for this one. So in that case, what do we have in this case? So in this case, we are going to have 750 times 30, and once we do that, we are going to have 2 to 500 watts. So we are going to add. So we are going to add, because we need to overcome this one to go, because power cannot be minus. Power cannot be negative. So power cannot be negative. So we need to add up the resistance of this. If this one is not there, then the power should have just been this times velocity. But because of this, we need to add it up. So you see, we need to add it up. So, and that is the reason why we have to do this. So we need to add it up. So that is how we do this one. Then let's see the let's see the last one. The last one. The last one, you are giving what? A force. The force is in form of vector I plus 2j plus 3k, which we know this means is 1 along the x, 2 Newton along the y, 3 Newton along the z axis, because we have 3 axes, y, x, and z. Along z we use k, along x we use I, along y we use j. The force is 1 Newton along the x, 2 Newton along the y, and 3 Newton along the z. The distance is also a vector. This is a vector, this is another vector. Now we said it says 4I plus 6j, which you can write as 4I plus 6j. This means is 4 meter along the x, 6 meter along the y, and also there is 0 meter along the k, because k is missing, so we can put 0. So this is how we get. So this is the force: 1 Newton along x, 2 Newton along y, 3 Newton along z, 4 meter along x, 6 meter along y, and 0 meter along this. So if we want to get the work done is simple as what we call dot product. That is f dot x. This is the same thing what we did the other time. We say work done is fx cos theta, because that is what we mean by this. If you can remember, when you have a vector a times vector b, it's always ab cos theta. That's why when we find work done is a scalar quantity, because it's dot product. It's going to be this: the magnitude of a, b, and the angle between a and b. That is, a is like this and b is like this. So this is the angle between them. So a dot b is ab cos theta. So this is how we find work done, is force dot x. Then how do you do that now? Let's put the value now. I plus 2j plus 3k. You close bracket, you put dots. So it's like a multiplication, vector multiplication. Now you put 4i plus 6j plus no k, that is 0k. Then if you're going to multiply this one, it's going to be very simple. You first look at I here. Look at the I here. The I you have here is 1. The coefficient is 1. In the other bracket, the I here is 4. You are finished with the y. Then you come for the j. You take the j in the first bracket. You look at the j on the second bracket. So the first bracket, we have 2 coefficient. 2j, that we just write 2. In the second bracket, we have 6j. So we just write 6. We have done with the j. That will come for k. For the k, we have 3k, 0k. That is 3 from the first one. The other one have 0. So all we need now to do is to now multiply and add. 1 times 4 is 4. 2 times 6 is 12. 3 times 0 is 0. Then 4 plus 12 will give me 16 joule. So this is how we do it. So this is how to do a vector dot product. You take the first bracket, you look for I. I is 1. You put 1. Then you look for the second bracket. How many I do you have? 4I. So you put 4. You multiply them. Plus you look at the first bracket, 2j. So we write 2. Then you look at the second bracket. We have 6. Then we put 6. The first one we have 3. We put 3. The other one we have 0k. So we only take the numbers. So we only take these numbers. So it is only the number. Here is 1. This is 2. This is 3. This is 4, 6, 0. That's why we have 1, 2, 3, 4, 6, 0. So that's how we do it. So that is what we have so far. So do you have question? So do you have question now? Yeah. Yeah. So what's the question? So the question, what's the question now?
Thank you, sir. Everything. Allah bless you.
Okay, so you're welcome. So we have finished the first part. So we have finished that of the first part of the something. So what actually remains later, that will be later. That is to look at 12